All right, back with the dreaded part 3 of a video. Um, but this one is take it up and see some homework examples here too. I think hopefully you got something that looked like this. You can pause the video and check your answers real slow if you want. There's exercise 3, number 1, counting by 30s, or counting by pi over 6s, of course, is what we're really interested in. Number 2, we are counting by, not 45s, by pi over 4s. We can see the rotation split by pi over 4s. Count by pi over 3s is counting by 60s. Right? Pi over 3, 2 pi over 3, 3 pi over 3 is actually just pi because the 3's cancel, and we get around pretty quick when we're counting by pi over 3's rather, by 60s. And then hopefully you had enough time there. This is the exercise 1, exercise 2. Again, pause if you need to. There are the answers, and on to an example. Was there something on the bottom that we missed? It's okay. If you didn't get that stuff there, ask about it in class. Here's an example. It says sketch 5 pi over 3 and show the related acute angle. So this is us getting used to this radians, and I'm not going to change this to degrees. I want to be able to do this just by radians, and that's why we did all this counting by fractions of pi. All right, so how am I going to do this? Well, where is 5 pi over 3? Well, if I count by 5 pi over 3's, I know that one of them's in, that was this one here. 5 pi over 3 is actually, if I had to look at it, would be in this quadrant. But how the heck would I know that if I didn't want to look back to this note? Well, I know that this cutoff is pi, right? Which is the same as 3 pi over 3. Why did I pick 3? Well, 3 is the denominator, right? There's 3 pi over 3. I need 2 pi over 3 more, and in fact, it's one less rather than 6 pi over 3. 6 pi over 3 is a full way around, so I'm thinking about pi over 3 less than 6 pi over 3. Right? This angle here, 3 pi over 3, 4 pi over 3 is over there somewhere, 5 pi over 3. Theta equals 5 pi over 3. And in fact, in drawing my 5 pi over 3, I'm the 1 pi over 3 less than all the way around, which is 6 pi over 3, or just simply 2 pi. And there I can see the raw. The raw is pi over 3. And notice this. This is what's kind of nice about radians, that when I have an angle, the denominator is going to give me the related acute angle. So when I have, an angle, and you don't have to write this down, but 7 pi over 4, what's the related acute angle going to be? The raw is going to be pi over 4. I just know it from the denominator, okay? That's kind of a fast way to remember. Then it says, state two angles coterminal with theta. All right. Well, no problem. We know that there's one of them. I could go 5 pi over 3 after a spin. So here, this angle right here, and I'm trying to figure out where I can start spinning. So a whole spin, and then 5 pi over 3. So this angle B, theta 1, is a spin plus 5 pi over 3. So, or I could think of it as 5 pi over 3 plus a spin. Right, this is once around. It's not 360. It's 2 pi in radians. That's one rotation. And notice, well, I got to tidy that up. I've got some fractions here I got to tidy up. So, and some people will be able to do this in your head, but, I'm going to common denominator. There's the 6 pi over 3 again. This is 11 pi over 3. And then if I wanted another one that's coterminal, I could go another spin. I could go 5 pi over 3 plus 2 spins. Right? 2 spins. 2 pi is a spin. And so I could do this work. And and common denominator again. Or I could think here, all I'm doing is adding another 6 pi. I get 17 pi over 3. And in fact, in general, what I could do, I could keep going. I could go any number of spins. So in general, I wasn't asked to do this. This is kind of bonus learning now. It's my 5 pi over 3, which remember is called the principal angle. That's the principal angle. Plus any number of spins. I could go 1 spin, 2 spins, 3 spins, 4 spins, any number of spins. N spins, where n is just some integer. You say, well, hey, Restall, what about this one? It's a negative value. In fact, it's just negative pi over 3. That's one of my possibilities. That's the first one that I saw. And you're absolutely right. And how does that fit into my... Well, try n equals negative 1. I'd have 2 pi, or 5 pi over 3 subtract 5 pi over 3 subtract 2n and, or sorry, 2 pi, and then I can get that, and it will be negative pi over 3 because I've got 5 pi over 3 subtract 6 pi over 3 is negative pi over 3. Sounds like dinner's ready. It's time to go.